Appreciating here today. This is first time on this platform, so bear with me if I'm a little clumsy working my way through it. Looks like I've got a total of 7 attendees now, so I'm pretty excited about that, especially since we didn't do a real good job, and it's on me, by the way, of advertising this webinar. So as we go forward in future webinars, which actually will build on this one today, we'll advertise it a little bit better, and because we'll have recordings of it if we need to make them available, assuming it's a part of the benefits that you get as an SCTE member, well, then we can make it available. So no more stalling on my part. Let's jump in. First thing I'm going to do is pull up the Cisco Packet Tracer network emulation environment. According to my screen, you all can see the environment now, so if nobody raises their hand, I'm going to assume that it's visible. I am aware that some of the text might be a little small for your screen. I am using a 24-inch monitor, so it's a little easier for me to see. You do have the Zoom capability, the Zoom functionality in the control panel for the GoToWebinar platform. So if you do need to Zoom, you can Zoom. If I move too fast or anything, you can certainly raise your hand and let me know, and I can double back or zoom in or re-explain any pieces of it. I will try to move relatively slow, especially as we first get started. First thing I'll tell you is that Cisco obviously is a manufacturer of network equipment, and while they are one manufacturer, they're certainly not the only manufacturer. They just happen to have in their line of certification trainings, they happen to have this platform that lets you emulate a network environment. And there are other environments like that by other manufacturers. We don't have a preference of one versus the other. It's just one that I'm familiar with and comfortable with. And it's something that is accessible to the general public to some degree. There may be functionalities or features that are not available unless you pay for certain things. I'm not aware of the distinctions there. I do know that generally speaking, you have to log into the Cisco One Identity universe, sort of log in when you try to use the software. But I do encourage anyone who is not familiar with it to visit the Cisco website and see if they're able to get the software. It runs as a fit client on your desktop, and it pretty much stands alone. And each of the devices in here is an emulated computer, an emulated PC or laptop, an emulated router or switch. It's not a full-blown image of that device running. There are other platforms that fully emulate those environments to where there's an actual image of that device running on your PC. This is not that type of environment. So what we'll find as we step through some of the webinar and some of the steps required for this particular lab, we'll find that there's some functionality that some of you may be used to or familiar with if you work in the network field. Oh, well, I know I can make it do this. Maybe it doesn't do that. So if we run across that, certainly don't worry about it. It's not a big deal, and it won't prevent us from doing what is in the lab. Essentially what I did was I sort of built my own ABC 123 kind of network engineering 101 environment or test plan or lab plan to cover all the basic things that I learned when I first started in the network engineering field. I came from the cable field as a cable technician. I started as an installer and a dropberry guy and put in digital cable boxes in houses when digital cable DCTs were brand new. And over the years, progressed in my career that's spanning about 22 years now, to the point where now I'm a professional network engineer and I manage teams of professional network and network security engineers and that sort of thing. So my point of view from this was, how do I get as basic as I can without being too basic? So there are some assumptions made here that I'm going to try to explain. If I don't explain them well, or if it's just Greek to you, speak up, let me know. We can double back. And if it becomes too complex or drawn out and going down that rabbit hole, well, we can just have a side conversation later. There's nothing about this technology or what we're discussing that I'm not willing to discuss on the side. Maybe a friendly email conversation because there's an issue, a particular piece of the technology or some assumptions that I'm making that just don't make sense to you. By all means, raise your hand. We'll get a little side conversation going. I'll share my contact information by the end of the presentation. So if we can get a really great technical conversation started about a particular foundational topic, if I can serve the needs of the community, my fellow folks in the cable business, well, then I'm happy to do that. So don't be shy. Like I said, use that raise that hand functionality as needed. So if no one has any objections, I am going to, let's see, I'm up to 9 attendees. That's good. And one of these may suggest that I have a question. Yep, there's a questions pane. I was warned about this. I have to keep my eye on it. Oak is unable to get the audio to work. That I don't know if I can solve. Let me see here. Bear with me. Yeah, Oak should be able to dial in like I think most everybody did, unless they use their computer audio. In a second. Dennis, you maybe if you have a second, you can just forward the phone number from the presentation to Oak if you have a second. If not, we'll have to address it later. Let's see here. Outside of that, I don't have any hands raised, so I'm going to jump right in. So let me get my environment pulled back up. And I want to make sure I have in the corner the audience view so that I know that I have the right thing in front of everybody. My big fear is that I accidentally have the wrong thing pinned up. Okay, so I will read to you what we have on the screen here. Essentially, we have inside this Go Packet Tracer environment, this network emulation environment, we have a number of devices that represent computers, PCs, and they represent switches, and they represent a router. And in the text here, in case it is too small, I'll read it to you ever so quickly. So for this lab, you are the newly hired network administrator for ABC Plastics Company, a designer and manufacturer of composite plastics. I made that name up. May really exist. I don't think it does. Just made sense because you had to come up with some fictional name. So this company is just getting off the ground, utilizing venture capital to open the business offices in Texas. Manufacturing is overseas, and communication with those facilities is completely outsourced at this time, which is code for we're only focusing kind of on this home office or this headquarters. Your responsibility is to build a network for the HQ that can support 3 departments with 9 users each. Well, we've kind of got our 3 departments sort of outlined here, like accounting, and then in the middle here, engineering, and over here, IT. Granted, there's not 9 PCs per department. I just did it with 3, but you get the general picture. So our responsibility, our requirements are to build a network that segments the 3 departments into different VLANs, or virtual local area networks, VLAN 192, 172, and VLAN 10, and allow all 3 departments to access everyone's computers. So every computer that has a person sitting there should be able to reach through this network every other computer somehow, despite the fact that we have 3 separate departments that are separated into different virtual local area networks, into different VLANs. I'm trying to keep an eye on my hand raising here. I think I'm doing it right. Okay. So the router, this fellow up at the top, will be a router on a stick. And that's a very, for those of you who aren't familiar with it, it's a very network engineering specific term for how a router manages connections to different virtual LAN environments. This router should be a router on a stick and should serve as the layer 3 connection between all 3 VLANs, as well as the DHCP server for all the hosts on the network. Only the router requires remote management at this time. So a management IP is sort of the hint they're dropping there. The first usable address should be used as the gateway for all 3 LANs, for all 3 local area networks. Again, accounting, engineering, and IT. Be certain that all PCs can ping all other PCs to confirm that your configuration is correct. So what I like to do in these labs is I like to sort of explain what the requirements are, what it is we're supposed to accomplish, and then at the end I like to explain how we would validate that. So if any of these webinars you are on with me in the future, you can expect that it might look like that sort of explain the environment, give out the requirements for the lab, and then give out the way to test to validate that in fact we've met our requirements, that if the network does what it's supposed to do. So I'm going to pause real quick here and ask if anybody has any questions. Throw up your hand real fast and let me know, and we'll address it. And if you have any concerns, or if something's not working right, or the images aren't clear or readable, let me know now. And if I see no hands raised in the next, say, 10, 15 seconds, I'll assume we're rolling along just fine. Okay. Everything must be working perfectly. All right. So let's dive right in. One of the neat things about this environment is that they have what they call the logical view that I'm hovering over with my mouse pointer here, but they also have a physical view, sort of the how can we emulate an actual room like a network closet or an IDF or an MDF or a telco room that looks like there's racks with equipment on it. So they have sort of a virtual physical environment, which is a little bit of a contradiction in terms. And in this environment, if I sort of drill in on this cute little pseudo fake map, I can drill into my corporate office and I can drill into my main wiring closet. And hopefully this is really clear and visible on the screen. Essentially, we have this rack, and I'm going to zoom out. There should be a zoom out button if I can find it. There it is. Zoom out. I'm going to zoom out just a bit. And what you can see is there's this rack, this network rack. It literally represents a 19-inch wide network rack for network equipment to hang in. And there are these tables in this little room, and I'll scroll over, and all these little PCs. So what's kind of neat about that is we've got PCs 0 through 8, which are our 9 PCs back in our logical view, PC 0 through PC 8. And we have in this rack, let's zoom back in, some network equipment. I'm zoomed way in. Hopefully that's very clear for everyone. Let me make sure this recording, it is being recorded. Okay, I got the little window that made it sound like it wasn't recorded. All right, so in this rack, we have a power distribution unit, PDU. We have this router that's just named router 0. And if you look back in the logical, oh look, there's router 0. Cool. So here's sort of what the physical router would look like if we were standing in a network closet in the room, physically touching the equipment. And you can even turn the power, this little button here, on and off for your virtual router. And you can install cards and slots and all fun things like that. So we got router 0 here again. And then we have a switch, a Cisco switch called aggregation switch. We have one called accounting and one called IT and one called engineering. So again, if you look, 1, 2, 3, 4 of those switches, it really does map to this logical environment. Make sure no one's raising their hands. Nope, good. So we're essentially going to emulate connecting all of these devices up with network cables. So I am going to come down to the devices and implements section of the window, the bottom left-hand section where you can add network devices like routers and switches. You can add end devices like PCs and laptops and servers. You can all do sorts of things. I'm going to go to the connections tab or the connections portion of it, and I am going to select a cable. Okay, no hands raised, good. I'm going to select a cable to connect between some of these devices. So between my router and my aggregation switch, pardon me, it's going to go from here to here. We need to use a cable. And if I look at the front of the router, I've got multiple ports, and I look at the front of the aggregation switch, I've got multiple ports. This should be pretty straightforward for us. So let's use a straight through. If I hover over it, it's supposed to tell what kind of copper straight through cable. It's at the, you can't see it, but it's at the very bottom of the screen in small print. So I'm going to select a copper straight through cable to go from my router 0. And then once I click on the router, I get to pick which port I want. So let's use fast Ethernet 0/0. It's a fast Ethernet port, which means it's a 100 megabits per second line rate capable electrical Ethernet port. So fast ETH0, oops, I already selected it. And I want to connect it to, let's connect it to fast Ethernet 0/4 on my aggregation switch. I think I'm going to use 4 as the standard for my, what we'll call like an uplink port. And if you're not sure what that means, I can explain it later. And you'll notice right away that I get this cute little green plug that plugs into this cute little green plug over here. And what you can't see is the invisible wire management happening, quote unquote, behind the scenes. And if you go back to the logical view, take a look at that. We've actually got a little cable going from our router to our aggregation switch. So the point of that physical environment is we can pretend that we're physically cabling up all of this equipment and doing things with it. Now, rather than stay in here and do that, I'm actually going to do the rest of my cabling through the logical view because it's a little easier to see. But you can always do it from the physical view should you desire. It can just be a bit more time consuming. It's a little faster to do it from the logical view. So now I need to get my aggregation switch doing the aggregating that it does. So each switch here, the accounting switch, the engineering switch, and the IT switch need to connect up to the aggregation switch so that they can all reach that router. So same thing, let's grab a cable, except this time because I'm going from a switch to a switch like devices, I'm actually going to use a copper crossover cable. So I'm going to connect from, let's say, port FAST 01 on my aggregation switch down to FAST Ethernet 0/4 on my accounting switch. And again, if you recall, I'm using sort of as a standard that FAST Ethernet 0/4 for my uplink to the rest of the network, so to speak. So let's do the same, and you'll notice we got some amber lights blinking on these. These guys are red or even off in our physical view, but we've actually got some amber lights blinking in our physical view. See, blinky, blinky, amber here. Green is what you really want, but we got amber for now. We'll come back to that. So let's take another copper crossover cable and go from port 4 on the engineering switch to port 2 on the aggregation switch. And if it's not apparent or obvious, there's nothing special about these ports. They're all configured identically. They all basically aren't set up to do much of anything except for sort of dumb switching. They just switch whatever Ethernet frames come into them. We'll have to do more explicit configuration in this lab to make them do the things that were described in our requirements for the lab, like the 3 segments of the 3 departments into the different virtual local area networks. So let's do the same thing. So we got amber lights again. These turned green for us, but down here, oh, they've also turned green as well. Great. So they stayed amber for a while, but then they turned green. By chance, does anybody want to raise their hand and tell me why we had amber lights for, say, I don't know, about 30 seconds before they turned green when we connected our switches together? Does anyone have a guess? If you do, raise your hand. If you don't, that's okay. It's not a problem. Okay, no guesses is fine by me. That's okay. So let's continue to cable this thing together. So again, I want to use for the uplink to get to the rest of the world, FAST Ethernet 0/4 off this IT switch, and I'm going to connect it to FAST Ethernet 0/3 on the aggregation switch. Again, no surprise, these are amber for a while, only because we saw it happen before, is why it's no surprise. And what I will tell you, since I didn't get any hands raised, is essentially there's a mechanism in the Ethernet world. There's a spanning tree protocol that runs on the typical Ethernet compliant switch. And essentially what spanning tree protocol does is says, hey, I see that we've been plugged in together. I see that we can send signals to each other electrically. I realize that we can do traffic. We can send network traffic. But my rules of my spanning tree protocol say I have to wait 15 seconds to send out these bridge protocol data units, to sort of send out these little signals, these Ethernet frames. And if I get any of my signals that I sent out back, if I get any of my frames back from some other place, then I know there's a loop in the network and there's a problem and I have to stop and block that traffic. So I'm first just going to send some out and wait and see if I get any back. After about 15 seconds, if I don't get any back, I think I'm doing okay. Instead of just listening to hear if I'm going to get my own frames back, now I'm going to start learning any MAC addresses that are coming across it. Everybody in the cable business should be familiar with the MAC address because they're so common in the way we manage our cable modems. And essentially, if you're not familiar, it's the physical address for the network interface card on any networked device. So all the physical interfaces get a media access controller MAC address. So I'll start learning MAC addresses in the next 15 seconds, and if I still haven't gotten any of my bridge protocol data units, my BPDUs, my spanning tree signals, if I don't get any of them back, then it must mean there's not a loop in the network. It's safe for me to go ahead and start sending traffic, and then I go ahead and turn green. And now these are capable of actually sending traffic between each other. So if you have questions about spanning tree protocol, write them down. Again, I'll give you my contact information. You're welcome to send me questions. We can discuss it later. But essentially, the purpose is to prevent bridging or switching loops in the network because they're bad and they create significant problems. So all the Ethernet compliant switches have ways of keeping those loops from happening or blocking them so that they won't cause problems on the network. All right, so we've got all 3 of our departmental switches, for lack of a better term, connected up to our aggregation switch. And we've got our aggregation switch plugged into the router, but you know what? There is nothing really happening here. These are red, and on our physical view, they are just dark. There's no blinky lights whatsoever. So like it's hard to see, but 1 is blinking green, 2 is blinking green, and 3 are blinking green because they go down to these downlinks to these departmental switches. But 4 is not really lit up at all. It's just doing nothing. So something's turned off. That means we need to turn something on before these start turning to our green color. We'll come back to that. Let's finish cabling up our lab environment first. So each of these PCs needs to connect up to the switches in their respective departments so that they can actually talk to other PCs or to switches or routers. So let's go ahead and cable them up. Again, like we did with the router to the switch, for a PC to a switch, they're considered not like devices. A switch is natively a layer 2 device in its functionality. So for different devices, we'll use a copper straight through cable. So there's only one port good for a copper Ethernet cable on this PC. It's just the one network port for the one network interface card. So we'll just plug into that and plug it into the first available port on our switch. And you'll notice again, amber light on one side. No amber here because PCs don't know anything about switching. They don't know anything about spanning tree protocol. It's not their job to worry about loops in the network. That's what switches worry about. So the one side is amber, and I pretty much, you can time it with your watch. It'll be about 30 seconds, 15 seconds for listening, 15 seconds for learning, then it'll transition to a forwarding state. So let's grab another cable, and I'll go a little faster through this because I'm probably droning on just a little bit, and we'll do the same. Copper straight through cable from a PC up to a switch. And I'll just do this a few more times without the long explanation, just to get it all knocked out. And I will keep an eye out for, this is a great time to, if you have any questions, now is a great time to raise your hand, feel free. All right. A couple more and we're done. With apologies for the delay, and thank you for your patience. Much appreciated. And again, you'll notice lots of amber lights that are going to turn green within 30 seconds of our plugging them in. So now we have our entire network environment all physically plugged into each other. I'll zoom out one click, see if we can see it a little better. Lots of cables and amber and green blinking lights. This looks more like a network closet we're used to seeing. Zoom out one more time, and you'll even notice, you probably barely see it on your screen, but the PCs have a cute little green cable going somewhere on top of that table and a cute little green blinking light. So there we go. I'll scroll down to it so it's easier to see. So there we go. We created our network environment from a physical perspective, but right now it doesn't do anything. There's no PC that can talk to another PC. There's work yet to be done. So based on that, let's see here. I'm going to expand my screen on the side here so I can keep track of all the attendees. I'm afraid of missing someone raising their hand. I don't want to leave you hanging. So that's why I keep switching over. All right. So let's jump in and look at this. So the first requirement we had is we have to have separate virtual local area networks. We've got to have separate VLANs. So let's start over here in accounting with this VLAN 192. And you'll notice by my little label under here that it was sort of our intention that the accounting department, all the devices that need an IP address, they should have an IP address in the 192.168.0.0 subnet. And that /24 is just shorthand notation for the subnet mask of 255.255.255.0. If you have questions on that, feel free to raise your hand. If you don't, and it's extremely rudimentary, don't worry. By the time we finish this lab, anything that feels too rudimentary to you, we will probably have skipped well past rudimentary. And if we get into future webinars together, we will leave a lot of this very basic stuff in the dust. In fact, you'll probably need to double back to it because some of it can get so advanced so quickly. So let's do that. Let's get this switch going. I'm going to put this in the, let me put this in the bottom left-hand corner of the screen. So when I click on the switch, I've got a physical environment in which I can sort of interact with the switch and some config parameters that I don't really ever use. And then we have the command line interface, the CLI. It's very common for network appliances from all vendors and manufacturers that network engineers historically have loved to use command line to configure devices as opposed to a graphical user interface or GUI. So when I first go into this switch to manage it from our network interface, from our command line, it's the host name for the device is simply switch, and we have our little prompt. You see I hit enter. We go a couple of times, a couple lines down, and you can see the screen scroll. I'm just in the mode we're in now. There's very few things. We're very limited in what we can do. We can't really configure anything. We can't control very many advanced features of the switch. So I need to enable, instead of the user executive mode that I'm in now, I need to enable the privileged executive mode. So I'm just going to type the word enable, And when I do, and I hit enter, you'll notice that the prompt changes. Instead of the little arrow or caret, it's now a pound sign. So the host name of the device, switch, is still there, but we have more commands available to us. And if I use the question mark for the context-sensitive help, this device and other manufacturers do the same thing. Gives me lots of hints of keywords that I can use to manage the device. So, in fact, what I'm going to do is to make this even more viewable is I'm going to expand it to about half my screen and see if that doesn't show up a little better for everybody. So we got a lot of different commands that we can choose from. The most important thing is we want to do configurations. We want to do change the configuration parameters on the switch to make it do the things we want it to do so we meet our requirements for our lab. Most specifically, we have to create this virtual local area network 192 we talked about and make sure that devices that are plugged into us can communicate inside that local area network. So first thing I'm going to do is, if you look at our list of commands that are available to us, we have one that says configure to let us enter configuration mode. So I'm going to type configure. Actually, I'm going to type CONF and hit the tab key, and it's going to auto-complete it for me because it's unique enough after typing CONF. And it says, well, what kind of configuration? Well, I want to configure from the terminal, so you say configure T. So config T or conf T is a very common thing that network engineers would type to configure these types of appliances in this platform. So there we have it. We are now in, our prompt has changed. We have gone from that privilege exec mode with the little pound sign to the host name plus the word config. It's saying, hey, you're in global configuration mode. You now have the ability to make changes on this device, some of which could impact its performance. So we just need to be aware that we have the power now. So from here, first thing I'm going to do is I'd like this switch to have the same name as what's in my little logical diagram up here. We called it accounting, so let's change the host name of this switch to accounting. So if I start typing host name, you can name it whatever you want. What do you want to call it? We're going to call it accounting because we're not that creative, and it does the job. So now our switch host name has changed to accounting. You can see the prompt has actually changed as a result, and if there are communications throughout the network from this switch, it can be known, that's its network name, it can be known as accounting. So step one, good, we've renamed our switch. Step two, we need to create these virtual local area networks. So again, VLAN 192, and I purposely picked 192 because it's kind of easy. I got the 192.168 network, I've got the 172.16, and I've got the 10 dot. It's just easy to say VLAN 192, 172, and VLAN 10. Easy enough. So let's create that. Let's declare the existence of virtual local area network 192. And by doing so, by simply saying, hey, VLAN 192 exists, we go into VLAN configuration mode. I'll go ahead and give the VLAN a name, because why not? 192 might not mean something to someone new to our environment, so we'll give them a human readable word so it actually means something. The 192 VLAN is specific to the accounting environment. That's where the accounting LAN lives, so we'll call it that. All right, I'm going to type exit to back out of VLAN configuration mode and go back into global configuration mode. You can also type Control-Z to do that as well. And now that we've created it and now that it exists, we need to figure out how to make the interfaces that our devices are plugged into communicate on that VLAN. So let's back up to the logical view here. And if you look, when I hover over the icon for my switch, got all these ports, 24 fast Ethernet ports plus 2 gigabit Ethernet ports. Now, we're not using the Gig E ports for this lab, but they are there. And we'll notice that this shows that we have 4 links that are up. That's why they're blinking green. It's going to be the 3 PCs in the department plus the uplink to the aggregation switch. And they say they're in VLAN 1. So VLAN 1 is sort of the standard. If you look, it sort of comes out of the box that everything's in VLAN 1 and everything talks in the same local area network and everything can communicate with everything whether you want it to or not. Well, we want to groom that communication a little bit more. We don't want everything to talk to everything. We really want to trim it down to the things where devices are plugged in and we want the traffic to go. So to do that, we're going to specifically tell these 4 ports, hey, you live or you can communicate in VLAN 192, not VLAN 1. So let's go back to the switch and do that. So if I do, let me do this. I will exit out of global configuration mode, and I will do a show running configuration. This is the configuration on the device as it's been created to this point. Most of it comes stock standard out of the box, and some of it is what we have, any changes we have made. So if I type show running config and I hit enter, we get things like, oh, look, here right there in the configuration commands is where we changed the host name to accounting. It probably said host name switch before. And then some other things that we don't have to mind at the moment, but they are in there. And if I hit the space bar to scroll further through sort of a screen at a time, we can see, I'm actually hitting the enter key to go one line at a time, we can see that there's no really special configurations for fast Ethernet 01, interface 02, 03, 04. They're all sort of generic out of the box, as I said. Very standard default configuration. Nothing special happening here. So let's go into these interface configurations and tell them specifically, hey, you're all about VLAN 192. So hit enter a couple times to get a good clean screen, making sure nobody's missing me on the hand raising. Good. I'm going to say again, configure T terminal. And I'm going to say, hey, I want to configure interface fast Ethernet 0/1. And that's the interface that actually plugs into PC 0. And one of the things you can do in the packet trace environment is you can hover over these interfaces, and it'll actually tell you, hey, oh, you're fast 0 on the PC, and you're fast 0/1 on the switch. Cool. It's easy to validate what's really there. That way you don't have to trace down cables, whether it's physically or virtually, because there are times when tracing cables is a nightmare. Anything that keeps us from having to do that is a good thing. So let's see. We're in interface configuration mode. Notice it says config-if, so interface configuration mode. And we need to configure this port on this switch to participate for this PC in VLAN 192. So let's use the context-sensitive help, the question mark, to see what commands are available to us. We've got all kinds of things: ARP, bandwidth, CDP, channel groups and protocols, duplexes, IP commands, service policies. You can even shut down the interface if you don't want it to work anymore. In this case, we actually want to do some switch port commands. Because this is a switch and it does switching, and we're not doing IP addresses, we're focused on switches and switching right now on our switches. We just want to focus on the switch port commands. So let's see what switch port gets us. So I'm going to type SW and hit the tab key to auto-complete that. And hit the question mark again. Because now that I have switch port in there, what other commands are available to me? If you don't know, you've got to figure it out, and this is one of the strongest tools to figure that out. All right, so we've got switch port access, switch port mode, switch port negotiate, switch port security, trunk, voice, all kinds of commands. Well, in this case, we have a PC that needs access to the rest of the network, that needs access to our virtual local area network 192, our VLAN 192. So we're actually going to say, let's make sure that it is an access port, not a trunk port, and I'll explain the difference later. Switch port mode question mark, we've got three options. We can be an access port, we can do dynamic, and we can do trunk. I will tell you in general, you're going to stay away from dynamic in almost every case when it comes to switching. You really don't want most of your switching to do things automatically, at least not at an enterprise small business level. You always want to do it manually. So let's say switch port mode access, because again, this is for letting a PC get access to the network, and that's probably all that's available. Yeah, if I hit question mark again, you'll notice I just get the little carriage return, which means you can hit enter at this point. There's no other words, keywords for you to put in here. So now I've made it switch port mode access, so let's do another switch port command. Switch ports, let's see, what are my choices? Access. Let's get a little more specific. Switch port access, what are my options? Hey, look at that. You can set the VLAN for when the interface is in access mode. Well, this is going to be in access mode all the time because we said switch port mode access up here. So let's type VLAN. And it says, hey, you can pick any VLAN from 1 to 4094. No surprise, we're going to pick VLAN 192 because that's the VLAN that all the PCs in accounting must live in by our network requirements, by our design ultimately. So I'm going to say switch port access VLAN 192. Again, there's nothing else to put here, so I'm just going to hit enter. And now the configuration for that switch port has been changed. So if I type a do show running config, I'll just type do show run because it will understand that's what I mean. And we hit the space bar and walk through it. Look at this. Now our configuration for Fast Ethernet 0/1 is not the empty default configuration it was before. It actually said switch port access VLAN 192, switch port mode access. We're explicitly saying, hey, any traffic that comes in on this port from anything that's plugged in will get pulled into or sucked into virtual local area network 192 to that specific LAN. And what's nice about these switches, what's powerful about today's Ethernet switches is you can have many different virtual local area networks. Even though they're all in the same room plugged into the same switch, you can make those local area networks feel like they exist in another planet, that they cannot communicate at all together if you don't want. So you have a lot of control. There's a great deal of control and granularity available. So now, we got the one for PC 0. Let's get these other ports for PCs 1 and 2 going. So let's see. If I hit enter and I say, okay, no, I want to do interface Fast Ethernet 0/2, you'll notice I can really shorthand it quite a bit because, again, it knows what I mean. You just have to practice with it until you get used to making sure you have enough characters for the command to be unique. Now I'm in interface configuration mode for Fast Ethernet 0/2. It's not as obvious because the prompt didn't change, but we were in 1, now we're in 2. I'm just going to press the up arrow, very similar to what you get in the command prompt, the Windows command prompt, to get to prior commands. And I'm just going to up arrow till I get to switch port mode access. And then I'll up arrow again until I get to switch port access VLAN 192. Great. Now Fast Eth 02 should be configured the same as 01. Let's do the same with the up arrow and do the same for port 3 that's plugged into PC 2. Switch port mode access, switch port access VLAN 192. Boom. All right. Now there's only one interface left. That's Fast Ethernet 0/4. But there's something special about Fast Ethernet 0/4. It's an interface between two different switches. So we won't configure it as an access port like we're plugging in a PC. Oh, look at that, amber light. Every time we put a new VLAN on a port, it seems like we get an amber light. I wonder why that is. Very interesting. So, there it goes, it turned red. How about that? So let's go into interface configuration mode for Fast Ethernet 0/4, and let's look at our options again. Again, it's a switch, and it's going to be about doing the switch's job. Layer 2, Ethernet. It's about switching frames. It's not about IP addresses or any of those other advanced features. Excuse me, I'm sorry, my voice is, my throat's getting a little dry. So, let's look at what we can do for this switch port. What commands are available here? Let's see, I want to say, since it's not an access port, the other option is, when we did the other one, we did switch port mode access, our options are access, dynamic, and trunk. We need this to be a trunk because physical links between switches are considered trunks typically, not always, but 99% or better of the time, because they could carry more than one VLAN. You'll notice that for our switch port access VLAN 192, we only got one VLAN we can pick from. Only one, any one access port can only participate in one virtual local area network. And again, one of the things, I don't know if I pointed out, is the PCs are not aware of the existence of that VLAN. They don't know anything about the VLAN. That's not their job. Their job is to do PC-like things and, prepare IP packets to go out. And then the network interface card prepares a frame to go, a very generic Ethernet frame to go to that switch. And it's not until it arrives at that switch that that frame actually somehow gets tagged with this special VLAN 192. So this is a trunk between two switches, and as such, it could have multiple VLANs on it. Now we're only going to put one on it for now, but we're going to see an example very soon about how you can have more than one. Let's see here, make sure I'm not missing any other questions. Oak got his audio working. I think that's a step in the right direction. Good. Let me get my audience view back here. Get my scroll down, make sure it's okay. I think I've got everybody good. I apologize again if I'm a little clumsy. GoToWebinar is a new platform for me. I've used others, but this is a new one. So again, maybe a little clumsy, and if I am, you can make fun of me all you want. We won't charge you any extra just because you got to make fun of me. So let's see, where did my switch go? There it is. So let's say switch port mode trunk. And when we do, holy moly, command rejected. Talk about getting rejected our first time out. It says an interface whose trunk encapsulation is auto cannot be configured into trunk mode. Well, I didn't know it was an auto. No one told me. Let's figure out how to deal with this encapsulation. So the concept of encapsulation is just exactly what I was talking about a moment ago. When traffic comes into this switch on one of those access ports, that frame, that Ethernet frame, which it contains inside, the IP packet, that Ethernet frame gets tagged with a specific VLAN. That tagging is the encapsulation that takes place. It's how we say, oh, you've been encapsulated and now live inside VLAN 192. So we've got to do something with encapsulation on our switch port command. That's not auto. We got to be more explicit that, hey, this is a trunk. So let's see here. Switch ports must be a trunk command. Let's try trunk. Switch port trunk. Look at that. Excuse me, encapsulation. Set trunking encapsulation with interfaces and trunking mode. Great. Switch port trunk encapsulation. And we have one option, .1Q. And what that's referring to is that's a very cute way of saying, hey, the type of encapsulation we use when we're trunking is IEEE standard 802.1Q. Pardon me. That it just sort of sets the protocol for how that where the tag lives and what the structure and the format of that VLAN tag is. So okay, we got one option here. Switch port trunk encapsulation .1Q. That's all we get to say. I hit enter. Let's try to go back and say, hey, I want to make this a trunk. I'm telling you explicitly, not dynamic. It's got to be a trunk, never an access port. Now when I say switch port mode trunk, it does accept it, but oh man, look at this. We go amber again between these two switches. So something has happened. Does anybody have a guess as to what might have happened to cause this link to essentially drop and start going back to listening and learning before it comes back up to green again? Why wouldn't it pass traffic? Any thoughts, any ideas, any suggestions? No? So it goes back to that spanning tree protocol. Essentially what the switches are doing is saying, hey, I was communicating, I was participating on this interface in this VLAN 1. Remember when we hovered over the switch, there's all those VLAN 1 all over all those ports. Now you're saying I got to live in some other virtual local area network. I got to live in another VLAN. What the heck? Well, what the switch does by default is that, hey, I don't know when I go into this whole other VLAN, I don't know if there's loops there or not. I have to figure it out. There could be a loop, and I can't take a chance on letting a loop destroy the network and take the network down because of the problems that those loops cause. So I'm going to back up and go back to listening mode. I'm going to listen for 15 seconds. If I don't get my little pings coming back to me, I'm probably good. Then I'll start learning MAC addresses for 15 seconds. If I still don't get my little pings, my little BPDU, spanning tree BPDUs back, then I will allow traffic to pass. And you'll notice in this case, both of those switches noticed something had changed and decided I'm going to be safe. So great. Now, if I'll just type N to get out of global all configuration mode, and I do a show running configuration, we'll notice right out of the gate, look at that. The FAST 01, 02, 03 identically configured for participating in VLAN 192. Fast Ethernet 0/4 says, I'm a trunk port. And so what's interesting is when I hover over it, everybody has their VLAN specifically set except for Fast Ethernet 0/4. It just has dashes. And the reason is because we could, if we wanted to, have more than one VLAN go across that. We could have multiple VLANs on the switch that could all go across this trunk link if we wanted to. In fact, it's a very common configuration. So maybe we'll see some of that in the very near future. But let's go ahead and go back into configuration mode, back into our trunk port, our interface Fast Ethernet 0/4, and let's be very specific about what VLANs can be on our trunk. Let's not leave it vague. Let's say switch port trunk allowed. Look at that. Set allowed VLAN characteristics when interface is in trunking mode. Well, it's always going to be in trunking mode. We were very explicit about that. That's why it says switch port mode trunk here. So switch port trunk allowed. Well, what can we allow? Hey, surprise, surprise. Specific VLANs. What VLAN would you like? I think we'll do 192 for the time being. Switch port trunk allowed VLAN 192. All right, and what that's saying is that's the only VLAN we're going to happen to allow across this trunk. May be the case that, let's see if I can acknowledge this question so that I know it's, hold on, the question mark stays there. It stays like he's asking me questions. What if I had a check mark? No, that doesn't do anything. Okay, I'm not worried about it. Let us see. Back to my screen. All right. Whoops. Thanks for your patience. So Now we've explicitly said only VLAN 192, and really that's a common practice, a pretty standard practice in a lot of environments because it's more secure that way. If you really limit it to only the VLANs that you want to use and not just any VLAN, which we can do, we can just use the keyword all here and allow all VLANs to go across that trunk. That's a little less secure. It creates the opportunity, the possibility of the traffic that you don't want coming there, whether it's because you use a bandwidth that you don't know to use or because it's a security risk. In either case, it's pretty common to trim it down to just the VLANs that you want to allow. There are use cases where you wouldn't, but in this environment, this is most likely the way you would configure it. So I think for the most part, our switch is set up and done. So I'm going to, again, say end to get out of configuration mode. I'm going to type the command write memory to save our configuration, because remember, we're in running configuration mode. Right now, as the switch runs, it'll keep our changes that we made. But if this switch restarts, reboots for some reason, it will revert back to its startup config and pull the last saved startup config into the running config. Well, if we save it, it's essentially copying our running config to the starting config, and now even if we get rebooted, restarted, power goes out, whatever, we get our exact same config back. So always remember to do your write mem or copy running configuration to startup configuration. So write memory is okay, I'm saving it, happy times. All right, I think we're done with the counting switch. Again, if we do a show running configuration, we can see where we made our changes on the host name. We can see where we made our changes on our 4 physical interfaces, our 4 ports, as we like to call them. And everything else is pretty much set to default, which is fine. So there's another thing that we can do. There's other show commands, by the way. There's lots of show commands on these devices. We have a ton of options. So if we were to say show VLAN brief as an example, we can get a quick rundown of all of the VLANs that are running on this device. We've got VLAN 1, the default VLAN, on a ton of ports. And we've got VLAN 192, what we named the accounting VLAN, on Fast Ethernet 1, 2, and 3. You notice we don't have 4 on there because that's the trunk. Remember, that behaves differently, it performs differently. So if I do a show interfaces trunk, I can see, we do have one interface, Fast Ethernet 04, that is in trunking mode. It's using this encapsulation that we specified. And here are the VLANs that are allowed on that trunk. Here are the VLANs that are allowed and active that actually exist in the management domain, saying essentially that we declared them to exist. And here are the ones that are in that spanning tree forwarding state. And again, what spanning tree does is it listens for 15, then it learns for 15, then it moves into forwarding state. Everything's forwarding, green lights are blinking, there are frames ready to pass. So we're in really good shape. So what I want to do in the interest of time is I'm going to go through the engineering and the IT switches in an exact identical fashion, but with VLAN 172 and 10. But I'm going to do it a little faster because once we get to the aggregation and router configurations, it's going to be pretty time consuming, and if I don't do these pretty quickly, it's going to drag us past 2 hours, and I don't want to keep everybody for too long. And so depending on where everyone's dialed in from, 2 hours from now could be your 6 p.m., and I don't want to do that to you. So let's jump into the other switches. Let's go ahead and close that little window there. Let's jump into engineering. I'm going to talk my way through it, and I'm going to move fast. Again, raise your hand if I go too fast. If you're confused, you have any issues, it doesn't make sense, doesn't mean if we can't answer the question right away, we could always answer it later. One of the things you notice when I first go, connect to this command line for this switch is, at some point in the recent past, it said, hey, Fast Ethernet 0/4 is up. Hey, 0/1 and 2 and 3 have changed state to up. Basically, because we plugged in and started turning green, the switch just logs the fact that that interface went up or down, which is great. It's good to know in case you ever need to check that later. So I'm going to do my configure terminal. To get into global configuration mode, the first thing I'm going to do is change my host name to engineering instead of to generic switch. Then I'm going to declare the existence, I apologize for the ringing in the background, the existence of VLAN 172 this time. I'm going to name it engineering. And I am going to, I might stop that. Oh, there it goes, sorry about that. So, the existence of VLAN 172, apologies again for the technical difficulties with the background noise. And back into global configuration mode. and I need to go to my interfaces fast 0/1. Well, hey, there's a little trick that you can do when you're do interface configuration mode, is you can actually do a range of interfaces at one time. So hey, might be faster to do 0/1 through 3 since they're going to be identical for our PC. And let's just do our switch port mode access and enter. And switch port access, shortcutting way too much here, VLAN 172. And if I end out of this configuration mode and do a show running configuration, you'll notice with just the range command and those commands, it went ahead and did all 3 interfaces, 1, 2, and 3. Pretty neat, pretty good. It's a lot faster. When you do a bunch at once, it just makes sense to use a range command. You just got to be careful you don't grab one that you didn't mean to grab. You always want to be thoughtful about that. So back into global configuration mode. Let's go to interface fast Ethernet 0/4, if I can type. And we'll do switch port. Let's see, I tried to do what? Switch port mode trunk last time, and it failed on me. That's right. You got to do the encapsulation. So switch port trunk encapsulation .1Q. Then, excuse me, up arrow twice and gets me back to my switch port mode trunk. Happy times. Spanning tree says, hey, something changed about my VLAN. I better back off. And then we'll say switch port trunk allowed VLAN 172. All right, I'm going to do a write memory so I don't lose my configuration. Or you can just type WRI as a real good shortcut. And if I do a show, let's see, what did I do last time? Show VLAN brief. I can see that one's still there. That's fine, whatever. It's on interfaces I don't care about. 172 has been declared. It exists, and it's on fast Ethernet 1, 2, and 3. Again, we don't see the trunk because it doesn't show up as an access port. But if I do a show interfaces trunk, if I could type, I could get it this time. There we go. Fast Ethernet 0/4. It's trunking 802.1Q. The 172, all forwarding, happy, ready to go. So basically, engineering switch is done and ready. We did a write mem. We're ready to move on. Again, I apologize for the pace, the rapid pace on these last 2 switches of our departmental switches. It's just a little faster this way. All right, again, we'll have a recording, and you can always ask questions. Don't be shy, speak up. All right, so for the IT department, and I happen to work in the IT department, so it's partial for me. Let's do the host name. I'm just going to call it IT. Can't get any easier than that. Let's declare the existence of VLAN 10, because remember we said we're going to do VLAN 10 for this department, and we're going to name it IT. Shocker, shocker, shocker. And let's go to interface configuration mode. Let's do interface range, fast Ethernet 0/1 through 3, please. Thank you. Switch port mode access, switch port access, shortcut too much access, VLAN 10. And then I need to go to interface fast Ethernet 0/4, my uplink to the aggregation switch and make it a trunk. So switch port trunk encapsulation .1Q. Switch port mode trunk. To me, it feels backwards that you have to do the encapsulation first and then do trunk, but it's made that way. It's a fail-safe, so you can't accidentally have mismatch encapsulations or any other issues. Being explicit is not a bad thing at all when it comes to configuring network devices. Let's see, switch port trunk allowed VLAN 10. Let's say end and write memory. And let's do show VLAN brief. Great, we've got 10 that exists. We gave it a name. It's on fast Ethernet 1, 2, and 3. And show interfaces trunk. And fast Ethernet 04 is trunking. It's all happy and it's all working. That's a good sign. All right, so we are done with our departmental switches. So again, what we've done as a quick summary, a quick review, what we've said is, hey, over here, there's this VLAN that exists. It's virtual local area network, numbered 192. We gave it a cute name called accounting, and that's only significant to this switch locally. The rest of the world doesn't know. None of these other devices know what we did over here, and none of those other devices know what we did over here on the engineering switch. So we declared the existence of that VLAN, and we said, hey, any traffic that comes in on these connections should get tagged with VLAN 192 and could potentially get shipped up on this uplink, but This isn't configured at all, so right now nothing could even happen anyway, even if the traffic could. Right now, as it stands, the only thing that can happen is that PC can technically talk to that PC or that PC. And this one can talk to this one or this one, but that's it. They can't talk to any other devices right now. All their frames sort of hit a dead end after these departmental switches because nothing's been configured up here. We've got to do more stuff to get these to be able to talk to each other. So interestingly, if I hover over any one of my PCs, you'll notice that it's not even showing an IP address right now. It's kind of nothing happening. Is that the case for all of them? Yeah, it appears to be the case. All right, that's fine. Well, nothing has issued out an IP address, so this is sort of expected behavior right now, right? The question, one of two of you may be asking, well, no, I should have gotten a 169.254 address. It's possible that as a result of the way we configured it, it had it and it went away. When the ports were changed to access ports, something could have changed. So no reason to dwell on that right now. They don't have IP addresses because we haven't given them IP addresses, and we haven't arrived at that stage of the lab anyway. So no big deal. No reason to panic. So let's move on to aggregation switch, because now we've got some bigger things happening. Now we're literally trying to aggregate all this potential traffic up to funnel up towards the router. So if you recall, for each of these switches, the uplink, that's fast Ethernet 0/4, is configured as a trunk. What should not shock you is each of the interfaces here on ag switch facing down towards these departments, sort of the downlinks for lack of a better term, they also need to be configured as trunks. They also need to be allowed the specific VLANs we want to have go across there. So let's go into aggregation switch, which has a very much out-of-the-box default configuration on it, and let's configure this fella. Make sure nobody's raising their hand. Nope. Okay. So I'm going to enable it, and I'm going to do my global config. Whoops, got to learn how to type. Global configuration mode. And again, let's do hostname first, to sort of take care of the housekeeping. And my keyboard may be a little loud. Again, if it's clickety-click and it's drowning me out, I need you to raise your hand and let me know. Okay, I'm trying to type softly, but I have heavy fingers a lot of the time, and I may not realize I'm drowning you out or drowning my voice out. So please let me know. Okay, this is interesting. If we look back in our log of what was incrementing before we ever got to this switch, as we plug things in, these links turned green. They came up. And then at some point I said, hey, I got this 802.1q BPDU on a non-trunk port, my fast Ethernet 01, which is set up for VLAN 1. Something's wrong. I'm blocking this. This port type can't be right. Well, that's because we configured our uplinks trunks for accounting, but we never configured trunks on this side yet. So it noticed something was wrong, and it did some blocking. It's exactly what I described to you earlier. Let me take a quick sip of my drink. I apologize. And again, I'm not really pausing for questions because you have the raise your hand functionality. So don't be shy. Speak up if you got something to say, please, or if you have something to ask. I don't mind. You won't hurt my feelings, and you won't ask a question that's dumb or that makes you look stupid. And I don't take for granted that everybody doesn't know everything. Some of this is reviews, some of this is new, and there's nothing wrong with that. So let's give this fellow a host name, and I bet you can't guess what I'm going to call it ahead of time. Yes, that's right. You guessed it. Aggregation. Sounds like a Hunger Games or one of those things, but whatever. So got a cute little host name on it. Now we've got 4 interfaces we care about, and I suspect we plugged into fast Ethernet 1, 2, 3, and 4. I think we did 1, 2, and 3 for our downlinks, and I think we probably did 4 for our uplink. Let's see. Yeah, fast Ethernet 0/4. All right. Now we can use the range command for some of the commands, but not all of the commands, because if you recall, I mentioned we want to keep our VLANs separate on whatever link should have a specific VLAN, only should have the VLANs we want to allow. So I'm going to walk through them one at a time because of the slight differences, even though some of the commands are the same. So let's do interface. Let's start with our downlink to accounting. I think that's 0/1. And if it's wrong, it won't work right. So I do need to double check that. Is it 0/1 that goes to accounting? Why, yes, it is. And what's really neat is, let me exit out of global configuration mode altogether by typing in. If I do a show Cisco Discovery Protocol neighbors, these devices Cisco has its own proprietary protocol, but there's also an open protocol called LLDP instead of CDP, excuse me, that specifically kind of does a little cheating between devices. Hey, is anybody out there? Who are you? Tell me about me. Tell me about yourself. So let's see. Plugged into my local interface here on aggregation, my 0/1 is a device called accounting. And it's this platform, this model of switch, and his or her interface is 0/4. Well, perfect. That's what I want it to be. So fast 0/1, I've just confirmed that I was in configuration mode for. That actually is accounting. Cool. I know accounting because I'm the architect of the network or the owner of the lab, or in your case, if you were to do this lab, person who can do it. By the way, I am able to share these lab files with you. So again, anybody, I'll give you my contact information. If you want to go through this lab on your own, you can absolutely do it. This isn't something where you got to try and write down everything and try to memorize everything and watch recording 20 times to do network engineering. You can actually do this lab if you get a hold of the Cisco Packet Tracer software through the appropriate means, and I can share the email the lab to you all day long. It's a learning experience. There's nothing wrong with that. We can totally do that. So let me keep going. Let's go back into configuration mode, global, then back into interface fast 0/1. We need to set our switch port trunk encapsulation .1Q first, and then switch port mode trunk, which I should have done a range for all 4 of them, but that's okay. Now we're going to say switch port trunk allowed VLAN. So it's only going to the aggregation switch. Any guesses as to what VLAN we should put on there? I suspect if anyone has any guesses, they'll raise their hand. Thinking about it, nobody raised their hands. It's VLAN 192. I know you were mumbling it to yourself anyway, but that's okay. So VLAN 192 is the only thing that's going to go on that trunk link. It's only about talking to this LAN, this virtual local area network that happens to span more than one switch. So cool, and it went into, because our VLAN changed, it went into spanning tree listening mode again. It's going to go through the process, make sure there's no loops, make sure there's no problems, because we don't know, us being this switch all by ourselves, don't know what else is out there, what else is plugged in. We got lots of ports that are up doing stuff. If we accidentally get our BPDU back, that's bad. It's bad for everybody. So we'll be safe. So let's go into interface. I'm going to use my up arrow, fast 0/2. Switch port trunk encapsulation .1Q. Switch port mode trunk. And switch port trunk allow VLAN. Instead of 192, this is going down to engineering. And you can tell because look, engineering is plugged into my fast 0/2. That's what I'm configuring. So we need VLAN 172 and only VLAN 172. And then let's do the same for fast Ethernet 0/3, which we see is plugged into the IT switch, which we know the IT to be VLAN 10, the IT department or virtual local area network. So up arrow a couple times for my encapsulation. It's actually 4 times. And now I'm going to only allow VLAN 10 because the only thing that should be talking in this little portion of the universe right here is on VLAN 10, and that's it. So cool. So now we have all of our downlinks to our departmental switches configured, and they are taking their time turning green and then amber, all that good stuff. I don't know why I keep pointing at my screen like you can see where I'm pointing my finger. I know, I'm a bit of a dork. I've been told that many times. So we got to do our uplink to router 0. And this is where the aggregation switch does its aggregationing. Okay, aggregation. Or aggregating. I like aggregationing. I don't know why. So this is where the magic really comes into play. This is where we actually are able to combine all 3 VLANs and send them up through another trunk and make them do the things, make this network do the thing it was actually we set out to do at the beginning when we set the parameters for the lab. So let's go into interface configuration mode for fast 0/4. We'll do switch port trunk encapsulation .1Q again. We'll make it a trunk port. But this time, we are going to allow more than 1 VLAN. We're actually going to allow all 3 VLANs. So we'll say VLAN 10, 172, I don't think I'm supposed to put a space there. That might error out on me. And 192. Now we're saying, hey, any frames that come into this switch, so if it comes in on VLAN 192 here on my fast 801, or if it comes in here, or if it comes in here, any frame, it's already going to have been tagged by the prior switch with that specific VLAN. If it comes in on any of those three VLANs, I'm going to allow it to go up and out towards router 0 on this trunk link. What's good is, even though they're all getting smushed into the same wire, the same trunk, physical trunk port, they're still colored in a different way. They're still distinguished by those VLAN tags. So the VLAN 10 traffic won't accidentally mix up with the VLAN 192 traffic. They've got their own tags to keep them separate. All we have to do is make sure on the router 0 side of the network, of that link, we're able to distinguish those. Hopefully that thunder outside is not too loud in your audio, and hopefully I don't lose power before we finish the lab, as I need another good 30 to 40 minutes to get done that. So cross your fingers, and if it fails, if you lose me altogether, we'll get together with SCTE, we'll figure out what we got to do, we'll preserve the recording, and then we'll figure out if we do a makeup or if we just do, schedule another one that just sort of follows on, or however we need to do it. So don't panic if you lose me, not the end of the world. So I'm allowing all three VLANs. I hit enter, it didn't complain because it's happy. So let's get out of global configuration mode, go back to regular privilege exec mode, and I recognize that I'm talking fast. It's specifically because, one, we're recording, and two, I want to hurry through some of the materials. This is one of the longest labs in the whole series. The others, some of them aren't that long. Some of them, an hour, hour 15 is plenty of time. So let's see. Show, like I did on the other switches, show interfaces trunk tells me about my trunks. And looky here, I've got 3 trunks. Oh wait, this is odd. I only got 3 instead of 4. Why is that? Oh, it's because I'm green or red here and actually dark on the physical. That's because something's not turned on. For now, we can ignore that, because once we get to the router, I think we got to turn something actually on, which all of these were on out of the box for the switch. Routers don't come all on. Routers are a little bit more sophisticated piece of equipment. Switches out of the box are intended that you could just plug them in and just plug everything into them, and everything can just talk to everything. That's why they're sort of made that way, with the everything on, everything by default. Routers aren't designed that way. They don't come quite that default out of the box where you can just plug in and go. Not a enterprise grade or commercial grade router. Your little wireless router at Best Buy, or your little wireless, Ethernet device, they tend to come with some auto configuration options. But at this scale, this level, small to medium business or enterprise environment, you really have to configure them. Routers are very intentionally not set up out of the box necessarily. They have some quick start things you can do, but we're network engineers, or we're working towards being network engineers, so we're more sophisticated than that. All right, but here's the thing. What should jump out at you is there's none of the trunk ports have any VLANs in spanning tree or forwarding state at all. There's none of them allowed in active and management domain. Anybody want to raise their hand as to why? Because we haven't had this problem before. What's wrong that none of them are actually allowed, even though we configured them to be allowed? Guesses? Anyone? Okay. So the reason is we sort of skipped this step because we got excited about our aggregation switch. We didn't declare the existence. If I do a show VLAN brief like we did earlier, the only VLANs this switch knows to exist are these weird ones that we never talk about and we never use ever, 1002 through 1005, so you can always ignore them. And then this default. There's no VLAN 192, 172, or 10 anywhere on the switch because I forgot to declare the existence of those VLANs. So let's go back into there and do that. Let's say, hey, there's such a thing as Virtual Local Area Network 10, and it's named IT. There's such a thing as Virtual Local Area Network 172, and its name is Engineering. There is such a thing as Virtual Local Area Network 192, and its name is something. Now they exist. Now if I do a show VLAN brief, let's see if they're in there. Ah, yes, they are. That's a good sign. Much better. This is the improvement. This is just a step that I missed, kind of on purpose, so we could see that. And then let's see if my show interface is trunk. Output changes now too. Yes. This is exciting. except for fast ETH 0/1, which goes down to accounting, which would be the 192 VLAN. That's not showing up. Let's see. Oh, there it goes. So for some reason, it didn't show up right away. I have a hunch it was because of changes we made by declaring the existence of those VLANs, and spanning tree probably kicked in. But now they're all forwarding. They all exist. Again, we're still down on 0/4, and that's because we got to go to the router and do some stuff, which is really the last step involved in this lab, is configuring this router and then checking our PCs as the instructions were set for us to verify that everything can talk to everything else, everything can ping everything else. So let's go to our router and configure that bad boy. All right, to me, this is the most fun part because it's a little more sophisticated, but it is a little more drawn out. It takes a little more time and it can be very confusing. So if you feel like I'm moving too fast, please raise your hand. If we go too fast through any of it and you want to ask about it later, let me know. If you want to know, hey, I know you won't answer everything in the universe, but where could I learn more? Let me know. We'll communicate all that information to you, okay? So no big surprise, router 0, also known as just router currently is a generic host name, has a command line interface. It works very much the same as our switches. Some of the commands are identical. Some of them are different because it does a different job. For a quick review, for those of you who aren't familiar or aware, by design, an Ethernet compliant switch has one job and one job only, and that is to switch Ethernet frames to different links on the network as quickly and efficiently as possible. It doesn't focus by design, by default, on IP addresses at all. Remember, the IP addresses in this IP packet that comes from, say, a PC or a server or something on the internet, that gets encapsulated into an Ethernet frame. And we know from our discussion that there's also an Ethernet tag, or excuse me, an 802.1q VLAN tag that goes on there, kind of further encapsulated or color that Ethernet frame. But that's all the switch is focused on, is how do I switch those frames as quickly and accurately and efficiently as possible. That's all I care about. I don't care about your dumb IP addresses. I don't care about what's inside the packet. All I care about is switch, switch, switch. The router, however, has a more sophisticated function. Like the PCs at the bottom of the diagram here, the router does pay attention to Ethernet frames, but it also strips off the Ethernet frames or decapsulates or de-encapsulates those frames to get to that IP packet, to get to those IP addresses, the source and destination addresses, so that it knows how to route those IP packets through to other networks. And that's sort of what's implied, the difference between switches and routers is switches they really are about switching within a particular local area network or virtual local area network in the case of our lab. And that's it. It's within that LAN. It's within one network that a switch really does its functionality and provides its, I don't know, expertise, for lack of a better term. Routers are the flip side of that. They are about how do I get a packet from one network or one LAN to another one, to a different one altogether. Because this got this destination IP address. It says I need to get to that network way over there. I, as a router, receive that and go, destination. Do I know which way to route that packet so I can head towards this destination? So routers really focus on getting an IP packet from one network to another network, from one LAN to another LAN. So that's why the commands are different, and that's why it's a little more sophisticated. So let's look at the router configuration that we need to do. The first thing we need to figure out is what's plugged into what, because we don't have the benefit of the show Cisco Discovery Protocol neighbors, and it's not because it doesn't work, it's because this interface is off right now. I don't even know which interface to turn on so I can figure the right one. Well, we have the luxury of our physical environment. We can just go look at our cables and hover over a network cable and it says, oh, that's fast Ethernet 0/0 on the router. It's plugged into fast Ethernet 0/4 on aggregation, which makes sense because we decided to use 0/4 as sort of our default uplink. And this is the router 0 is sort of the uplink to aggregation. We can also hover over it in the logical view and get the same information. So in any case, fast Ethernet 0/0 is the interface on the router that we need to configure. So let's start there. Why don't we go into interface configuration mode, 0/0, and simply say, let's see, what are our options here? We've got ARPs and bandwidth and this and that and the other. We've got a shutdown command. Let's do a show running configuration, and let's look at fast Ethernet 0/0. Looky there. No wonder we have no blinky lights. No wonder everything's sort of red or blacked out. It's because it's currently shut down. How can I undo the shutdown command? Again, using the context-sensitive help, my little question mark. I can say no, undo a command. Okay, cool. So let's say no, shutdown, and see if something happens. Well, surprise, 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 as Gomer Pyle would say. The interface turns green on the router side and turns amber on the switch side. And that's because the router isn't really paying attention to spanning tree and doing spanning tree. That's a job for switches. That's a job for a lowly switch. I'm a router. I'm too sophisticated for that. But the switch, aggregation switches, in fact, it's gone amber. It is doing that job. Something's changed. An interface came up. I got to keep an eye out, keep an ear out for my BPDUs, my spanning tree bridge protocol data units, just in case there's a loop. And 30 seconds went by. He found no loop. He's happy. So let's go back to this router. And really, we still have a very generic configuration on it. Now we need to get a little more sophisticated, a little more explicit with how we do it. So if you recall, aggregation switch is currently allowing traffic to pass on that trunk, switch port trunk allowed, VLANs 10, 172, and 192. 3 different VLANs from 3 different departments. We've aggregated them together, and we're allowing them to flow to this fast Ethernet 0/0 on our router. But now we need to tell the router how to distinguish between these VLANs. Because routers don't, by their because of their native characteristics, they don't have trunk interfaces like we do on switches. You don't say switch port mode trunk. You can't even do a switch port command. In fact, if I start typing switch port, what about switch port question mark unrecognized? I don't know what are you trying to tell me? If I use my context sensitive help, there's no switch port anywhere in here, and there's not a way to make fast Ethernet 0/0 into a switch port. It's designed to be a routed port. It's designed to have IP addresses on it and doesn't care about things like spanning trees and VLANs and trunks. So we almost, in a sense, we have to trick the physical interface fast Ethernet 0/0 into being 3 separate interfaces all at the same time. So when the VLAN 10 traffic comes up to it, it goes, oh, I handle it this way. When the VLAN 172 with that tag comes up, oh, I handle it this way. 192, oh, I handle it this way. So we got to be a little sneaky, and this is where this router on a stick concept comes from. We got to basically route between 3 different virtual local area networks as if they were on 3 different physical interfaces when they're only on 1. And the way we do that is we create sub-interfaces, essentially a virtual interface within the physical interface, so to speak. So if I say, let's see, I'm an interface, let's exit out of here because I want to Control Z, oops, hit the wrong button. Let's say interface fast Ethernet 0/0. But now I'm going to use my question mark. It says, hey, if you want, you can put a period here. You can do a slash, but you can also do a period. I'm going to do a dot or a period. Actually, dot's probably a more appropriate term. Then I'm going to hit question again for my context-sensitive help, because if I don't have it all memorized, why not let the router do the thinking for me? So now it says, look, you can have another number between 0 and, merciful heavens, I think that's 4,294,967,295. We got a lot of choices, more than we hopefully will ever need. Well, I'm going to pick 0/0.192 for this sub interface. And you'll notice that my prompt changes to a sub interface configuration mode instead of just interface configuration mode like we saw here. It recognizes that we've created a whole new interface that did not even exist before. It says, okay, cool, there's another interface. It's virtual. It's a sub interface. It's the 192 interface. And I'm picking 192 because I'm sort of planning ahead of time what I want to use this sub interface for. No big surprise. We're going to try and map that to VLAN 192 and the accounting department. So let's see, what are my sub-interface commands? A little bit shorter list, which is probably a good thing because it's less confusing that way. So the first thing we're going to do is let's start with how do I make it like those trunk ports that I created, those trunk interfaces I created on my switches. Well, there it is right there. There's no trunk commands, there's no switch port commands, but there is an encapsulation command. So let's say encapsulation, hey, no surprise, only .1Q is allowed because that's the standard for the universe now anyway. And if I use my context-sensitive help again, it says pick a VLAN, any VLAN between 1 and 4094. Not shockingly, I'm going to pick VLAN 192. Now, that doesn't have to match the sub-interface number that we chose, but it's really good practice to do it that way. It could get very confusing if they don't match. It just makes, to us, for this lab, every time we think 192, we think that left-hand section of our diagram, that accounting section, that accounting switch, that VLAN 192, just keeps it all together. We don't go crazy confusing ourselves. So great, we've created a sub-interface and we said, hey, any traffic coming in that's tagged VLAN 192, come over here to this .192 interface. But then what do we do with it? Well, if this traffic comes in tagged that way, it ostensibly came from one of the PCs in the accounting department. So we need to have an IP address for those PCs to talk to. So one of the things you notice in our commands is we have the ability to give an IP address to this sub interface, not the physical interface 0/0, but the sub interface. So I'm going to say IP address, and it says, okay, tell me what your address is. 192.168.0.1. Let's say .1. We'll make .1 sort of the gateway to the rest of the universe for all the PCs in the accounting department. And we do have to do a subnet mask. So like I told you earlier when we started, the /24 is just shorthand or what they call CIDR notation for 255.255.255.0. If you want to know more about that, let me know at the end, or again, I'll give you my contact info. I'll be happy to discuss it. Now we've given an IP address to the sub interface. The first thing we've given an IP address to is this entire lab. And it's up already because it's already green and it's already happy doing its job. So cool. Now let's exit out of there and let's do the exact same thing for the engineering department, our VLAN 192 environment. We're going to do the exact same thing. So it's /0/0.172. Why not? Let's make it match the VLAN. Now it has come alive. It is alive, as Dr. Frankenstein would say. And we need to set that encapsulation, because if we don't, coming in tagged, it won't work. It won't go anywhere unless we say how to handle traffic tagged VLAN 172. So encapsulation.172. And let's give it an IP address of 172.16.0.1 with the same subnet mask as before, because you'll notice on the screen here as I hover, we want it to be a /24, pretty generic, pretty standard size LAN subnet. 255.255.255.0. And let's do the same for the IT department's sub interface on the router. So .10 is now alive. We are going to say that would be for tag traffic.1Q10. And we are going to give it an IP address, and I'm totally cheating here by just using the up arrow because it's faster. So 10.0.0.1. Again, that's sort of the gateway address, or the address that all the PCs in that department use to get to the rest of the network universe. All right, so I realize I probably went through that section a little fast. This is because our time is growing short, and I want to make sure to get through it quickly. Some of those concepts, if they are a little advanced, just let me know. We can talk about them more in detail. So what I'm going to do now is I'm going to get out of global configuration mode. And we never gave a cute host name to our router, but I think we'll call it router for now. I'm good with that. And I'm going to use my show commands, show IP interface brief. I want a quick snapshot of these interfaces on this router. And here's what I get. I got, hey, you've got an interface fast Ethernet 0/0 that is up and it's running. You've got a sub interface .10 and 172.192 that have these IP addresses that you gave it to them. And the reason we know we gave it to them is because they were manually set. We did not use DHCP to create those IPs. We just said that's what they are. And they're up and running. And so it's a very happy environment. So really the only thing left is, in order to meet our requirements for our lab, is we've got the layer 3 connection up between the VLANs. That's what those sub interfaces do. But we need to figure out how to make the router the DHCP server for all the hosts on the network, for all 3 VLANs, all 3 environments. So, and we did already used the first usable address in each subnet, the .1, for the gateway in our LANs. So right now, again, no PC has a usable IP address, which is a problem. So we need to, sorry, I got a flow going around here. We just need to get this router to act as the DHCP server per the instructions for the lab. So rather quickly, this is going to be a little quick, so my apologies in advance. From global configuration mode, we need to set up these DHCP pools of addresses and set up some parameters, some DHCP scope options, so that devices plugged into these environments can get an IP address. So I'm going to start with the IP command, and Content Sensitive Help says I get to use DHCP, and I get to create a pool. So let's name this pool accounting. Why not? How easy is that? And that's it. Now we're in DHCP pool configuration mode. So our options here are a little bit different. One, we want to set the network. What is the range of addresses that are available in this DHCP pool? So let's do the 192.168.0.0 network as I specified in the drawing in the logical view. And you got to have a subnet mask for it, so 255. How big is this range of addresses? Well, it's that big. It's a /24 big, or 256 addresses big, roughly. And then we need to say, hey, when someone gets an address from us dynamically, what should we tell it its default router is, its default gateway? So we use the default router option, and we say, hey, your default gateway is 192.168.0.1. It's me. It's my 0/0.192 subinterface. If you want to get to another network off of your network, send it to me. I'll handle getting it to the other network. That's what a router does. That's what we described earlier. And I think that's all we need for scope options. Yes, that's all we need right now. So we've created the pool for accounting, and we set the network size, and we set the default router. Let's create the pool for the engineering department. And we're going to say the network is the 172 network /24. And we're going to say your default router is 172.16.0.1. It's our 172 subinterface. And let's do the same for the IT department. Again, I know I'm going through this rather quickly, so I apologize. And we're going to say the network is the 10.0.0.0 network. Oops. There we go. And we're going to say the default gateway to get out of that particular LAN environment is 10.0.0.1. Whoops, mistyped it there. Okay. We're going to exit out of DHCP config mode. Now the problem is if I do a show IP DHCP pools, I think it's pool, it will tell us about all those pools we created. You've got 254 addresses that are used right now. You've got the range of 192.160.1 through 254. You've got the same for your engineering pool, and you've got the same for your IT pool. The only problem is one of the addresses in these ranges is the address for the gateway. It's the address we already put on our router. We can't have that accidentally be given out to a PC in the network somewhere. So we have to go back into global configuration mode and say IP DHCP excluded addresses, and let's exclude 192.168.0.1 and 172.16.0.1. We do not want those given out to a PC. Two devices can't have the same IP address on the network. It's simply not allowed. In theory, they should never exist anywhere in the universe. There are reasons why they are duplicated, but they technically can't talk to each other. So now we've excluded our gateway addresses, the addresses that we have here. We do a show IP interface brief, and then I do a show IP DHCP pools. You can see, now we have some addresses that are excluded, which is good. It actually says 3, and I won't go into why that is right now for the sake of time, but if you know your subnetting, you should know why 2 addresses are already not usable anyway, and then we added a 3rd. So we've got DHCP set up. The question is, are any of these PCs out here still asking for DHCP IPs? Have they given up? Did they work? I don't know. Now I can hover over the PCs to find out, but what I want to do is let's ask the router first. Hey, show me any IP DHCP bindings. Has anybody signed up and gotten an IP from us? Nope, not a one. Not a single one. And that is probably because these PCs long ago gave up asking, or they're set to static and we need to set them to dynamic. I bet you that's what it is, because they should have done an auto configuration of that 169.254 address. So let's grab a PC, say PC8 in the IT department. Let's go to the configuration tab. In the configuration tab, oh look, it's set up as a static. So we just need to say, no, do your IP address stuff dynamically. Ask for it dynamically, and let's see if you get it. Well, gee, within what, 2-3 seconds, we got an IP address on that bad boy. Yeah, that's cool. That's a good sign. So let's do this. Just for grins, let's go back to the router and say, hey, has anybody signed up for an IP yet? Boom! MAC address that ends in BD4D, Bravo Delta 4 Delta, in fact, has an IP address. We gave one out, and as far as we're concerned, he or she can use that address to the length of our lease expiration, which currently shows no expiration. So we must not even have the lease expiring. For now, we can leave it like that. But we got to hit all these other PCs real quick and say, hey, you're supposed to be dynamic. Get on the train here. So it would have been fast if I set them to dynamic to begin with before we started the lab, but I didn't. My apologies. But thankfully, in the emulated environment, it's really quick for us to do it. So I'll take the whole 15+ seconds that it takes to switch them all over. We'll hover over them and see if they got some IP addresses, and if they did, then that's a good sign. And then all we have left to do is test, hey, can we ping each other? The rules say we're supposed to be able to ping each other, so let's see if we can ping each other. So we'll start with, it's been long enough that maybe all of them have grabbed an address and have a binding in here. Let's look. Let's go to DHCP pool first, and let's see what they show in use. I've got 3 leases in accounting. I've got 3 leases in engineering, and I've got 3 leases in IT. I think they're all in use. Look at our bindings. Boom. We've got 9 bindings. 3 PCs per VLAN, per LAN environment, per subnet. So I think we got it working. The only thing left to do is make sure everybody can ping everybody. Did we do that right? Well, we know that our VLAN 192 reaches all the way to this router and back. And the reason we know that is because we were able to successfully issue out a DHCP IP. A DHCP request came out, hit here, got tagged with VLAN 192, came across here, arrived at the IP, the subinterface 192, and the router was able to say, oh, this is the DHCP request. I can do that. That's a service I perform, and it sent it back. So we know the connectivity works for all 3 VLANs. Really don't have to do much there. It just doesn't work between the VLANs. Well, the first thing I want to do is, hey, router, do you know how to get to all 3 of those networks? Let's ask the router to show us the routing table that it has to see if it knows. Now, it should, but let's just check and see. And what it says is, hey, I may not know how to get to anything else in the universe because this is sort of a dead end, but I do know how to get to the 10.0.0/24 network. I do know how to get to the 172.16, and I do know how to get to the 192.168 networks. I've heard of them. I know about them. In fact, I know about them because I'm directly connected to them. So I can route to those things all day long, which means just by virtue of this router living in each of those 3 networks, because again, a router sort of separates networks or allows traffic to get between networks, it can participate in multiple networks. That's its whole reason for being. Switches don't do that by default. So the only thing left to do is, yeah, okay, you say you can get to those networks, but let's prove it. Why don't we close this? Let's grab PC8 in the IT department that we happen to know has a 10.0.0.2 address, but we'll do it as if we can't see it there. We'll just pull up a command prompt. Let me get this bigger on the screen. Hopefully you can still see. Let's go to a good old-fashioned DOS prompt or command prompt and do the old-fashioned, what is it, IP config command. Oh yeah, I'm 10.0.0.2. I'm happy, everything's working. So can I ping my local gateway, 10.0.0.1, as it was defined to me? Sure can. I've been talking to them for a while now. But can I ping one of these other PCs? If I hover over 7, that's a .3 address. That's a .4. Here's 172.16.0.2. .3, .4, and predictably, because of the order that I turned on the dynamic process for each NIC, can I hit all those? Let's try it. Can I ping 192.168.0.2? Can I hit PC2? It's not working out of the gate. That's got us nervous. That could be a problem. What does that mean? It's working. Not surprisingly, there's a process that had to take place where the router was able to figure out, hey, what MAC address goes with 192.168.0.2? I know how to get to that network, but I don't know what actual NIC to send it to. How do I do that? That's why we lost one ping, but it's working. If we do the same for .3, we'll have the same process. There's that address resolution protocol, the ARP protocol that has to take place at the router level, not at our level. We don't need to know the MAC address over here because MAC addresses are only significant on a local area network. They only matter in this little slice of the universe. And let's hit some 172.16 real quick just to say we did. And wait for the ARP process to take place. And it does, and now I'm paying. So without hitting every PC, because I'm very confident that they all work and I want to be, cognizant of the time we're taking, basically the environment does what it's supposed to do. We physically connected all the PCs to their departmental switch, a switch that's dedicated to their department. These are 24-port switches, Cisco 3560s, and we connected each of these departmental switches to another 24-port 3560 that we call the aggregation switch, and we connected that up to this router, and we call this a router on a stick because this router routes between different networks, but all across the same one physical interface, and it behaves as if it's a trunk, even though the router doesn't really know what a trunk is. So we cabled everything up. We've enabled the VLANs to talk all the way across to the router. You'll notice VLAN 10 doesn't go on this switch or this switch. They don't know it exists. You'll notice that none of the PCs are aware of the existence of any of those VLANs. They don't think any exist. They just know they can send IP packets and they get where they're supposed to go and they're happy. And everything can ping everything, at least the limited testing we did. So we've accomplished all the goals in this lab. This point, I definitely am looking for a response of any kind from the group. In fact, as many as possible. I might just unmute all of you, to be honest with you, because it's probably faster. Questions, thoughts, concerns, anything I could double back on to clarify for you? Yeah, I'm going to unmute you guys because what's the worst that could happen? I'll just mute you again if something goes wrong. Anybody got any thoughts? Well, I tried to unmute you, it didn't work. I said, yes, unmute these nice people. Bear with me while I figure out why I'm not unmuting you. Yes, unmute.
I physically unmuted myself, Patrick.
Say again?
I had to physically unmute myself.
Yeah, I guess I don't have the ability because I'm not the organizer. I don't have the ability to unmute everyone at once, so I apologize for that. But in any case, anybody any thoughts, any feedback, anything you want to tell me? Did I say something wrong? Did I state anything incorrectly? Was this too basic? Was it too advanced for anyone? I do need to know that because we want to make sure we're targeting it to the right people, the right audience. It's something useful. Okay.
Yeah, this is Dennis.
Yeah.
Just my feedback. I've had some of this. It's been a while. It was basic enough that I could follow along. Some of it was stuff I recalled. Some of it I hadn't seen. So I got something out of it, but also knew some of it. So. Okay.
I think that's the ideal. The ideal is you have some foundation, like where you are at, Dennis. Scott's probably in the same place. It's hard for me to say for the rest of the attendees. Excuse me. But it's really targeted for, you kind of have a very broad, basic baseline or foundational knowledge, just at the bare minimum. I know what IP addresses are. I know what MAC addresses are. I have a general idea of what switches and switching are, a general idea of what a router does, but I'm kind of fuzzy past that. It's trying to build on that. And each lab after this, each webinar after this will have, it's going to build on this identical environment where the next lab is going to be that we sit down, excuse me, and I have a fictional trouble ticket where, hey, something's not working right. You got to check it out and figure out what went wrong. on this exact environment that we just built to a T. It's identical. We're taking this environment and carrying it over. So it's really going to build on that. So for folks who have seen this before, for the Scotts and Dennises out there, it's going to move towards advanced pretty quick for you. For the folks that are 5 and 10 year network engineers, there is very little I'm going to show on here that is going to blow you away. Some will be like, oh, that's right, I forgot all about that. Or, yeah, I forgot how to do that, but I knew what it was. And that's okay, too. You're welcome to be here. You're welcome to join. You're welcome to be a part of the conversation by any means. We really want the participation. But I don't want anybody being hard going, this is dumb. This is so elementary. I don't like it. There's no point. Because that's a waste of your time. You have better things to do with your time. But if there's value to you at all, definitely keep joining us, keep participating. We're going to properly advertise the next one and grow our base of folks that are attending. And if things go well, we'll grow it quite significantly. So that really wraps it up. Again, any other questions, any other concerns? Anyone have any thoughts that you're worried about? Anything I could do differently as a result of this? Any questions about SCTE at large that we could answer? Okay, I am going to take silence as I have completely covered everything perfectly for you. So again, we're going to attempt to do more of these in the future, and we hopefully will have you on board. We'll try to get them out there on the scte.org website, on proper email announcements. If you're a Gateway Chapter member, if you're affiliated with Gateway Chapter, you would be on our mailing list, and if you're not, that's okay too. But I thank everybody for your time. I thank you for your patience. Some of my little bit of small technical difficulties, some of my little bit of fumbling through the platform a little bit. Hopefully my presentation piece of it, the meat and potatoes of it, was really meaningful and helpful for you, okay?
Thanks for your time. Appreciate
it. Absolutely. Thank you all for joining. Dick, did you have a question?
Thanks, Patrick. Nope, I was going to say thanks a lot.
Absolutely. All right. Well, I appreciate you. Thank you, Jessica, for helping out, and thanks everyone for attending. I hope to see you again soon. Thanks. Bye.
Good job.
Thank you. All right. Jessica, if you're still around, is there anything else we need to do before we shut down? I don't want to turn it off too early if I'm not supposed to. You may have walked away. I don't want to turn it off and ruin the recording. That's all I'm worried about.